Hi, and a very good day to all of you. I'm Zian Kao, an aeronautics and astronautics student from the University of Southampton, Malaysia. If you feel the topic of digital transformation of engineering sounds a little unexciting to you, please don't go first, because the story that I will be sharing might happen on you someday. It was something during my internship with a consulting firm. I had 2 shots of espresso at the midnight. Why? Because I was halfway conducting a flow simulation with a combination of 50 sets of parameters. I had no choice but to stay overnight so that I can keep going on to modify the designs and run simulations. I was really thinking, how nice would it be if this whole thing turns automatic? And the next day, and as you expected, I messed up all of my files, and some of the results were just completely illogical, just because I was too exhausted. While I was really disappointed in myself, my supervisor showed me something developed by Dassault Systems, the company that owns SolidWorks, which I consider as a game changer for engineering. He uses software on the cloud to integrate all of these processes together so that they run automatically on the background. And I have to say, I was really impressed by the reduce in effort of time by utilizing these digital processes. So why I'm telling you this is because all of this explains digital transformation, a transformation process and redefinition of an organization by fully leveraging the potential of digital devices. We noticed 2 things for this change. A lot of human work and error have been eliminated, and time is conserved. And this is what I'll be sharing with you today. How will all of these digital technologies transform the way engineers work, and how does it benefit us? You might be curious, how does all of this matter to me? So first of all, by unleashing the potential of digital technologies, we will see more innovative engineering methods that never existed before coming to life. Smart devices will be starting to handle a larger portion of our workload, thus simplifying steps required for engineering processes. Advanced communications technologies such as the 5G have also allowed us to connect with each other more seamlessly than how it used to be, so that we can exchange information more easily with each other. All of this subsequently eases our workload so that we can stay focused and productive on the task allocated to us. Also, the time used to complete a project will be very much shortened. We can help our company to save computational cost while creating business values for our company. By adapting and making full use of these technologies, we are actually better fitted in the next generation of engineering so that we can remain competitive among the industry to create values for the human beings. It is really exciting as we advance on a rapid pace towards the fourth industrial revolution. It is a futuristic generation driven by intelligent and fancy technologies, including system integration, Internet of Things, cloud computing, and also additive manufacturing, as you can see on the slide. These are some of the pillars for the Industrial Revolution, and at the same time, they serve as the foundation of digital transformations. But today, we will only be mainly focusing on how cloud computing and system integration transforms engineering. I believe that everyone has more or less enjoyed the convenience brought to us by cloud services. So basically, the cloud is a virtual environment which allows us to run services and applications over online internet servers, and the cloud has become a very significant part of our life due to a number of benefits, including its flexibility and, as I mentioned before, the convenience, especially when we are trying to share files with our colleagues or our friends. Just imagine by 2025, there will be more than 200 zettabytes of data stored on the cloud. And this is actually equivalent to 50 trillion of 2 gigabyte movies, which takes forever for you to finish. And this figure shows the increasingly important position and potential of cloud in our daily lives. So adding on to that, cloud computing is something that brings cloud services to the next level. Cloud computing, in short, means that our engineering processes and computing services, such as applications, simulations, and storage, revolve around such cloud services instead of your own computer. This service can be based on either internal servers of companies or provided by the third-party service provider such as Amazon, Google, and also IBM Cloud. These providers usually have data centers consisting of powerful computers networked together. And these computers, when they are combined together, can achieve things that normal computers can't, just because they have so much of computing power. This opens up more opportunity to perform more sophisticated engineering tasks. When this is combined with system integration, we will see how the synergy of two of these results in a revolutionary engineering experience. So let us consider a scenario like this. You are a simulation engineer working with a team of different engineers, which consists of a project lead, a design engineer, and also a materials engineer. Your team has been assigned by two customers, A and B, to develop a rear wing for a Formula One car. But A and B are based on two different locations and they have different requirements that you have to fulfill. And of course, with a tight budget, your team will need to select the best combinations from a list of manufacturers and suppliers available so that the prototype can be delivered to your customers before the deadline and of course with the lowest delivery fees. These group of people, or also known as your stakeholders, are parties which provide support for your project so that you can obtain the resources necessary to achieve your project goals. What frustrates you the most is when you work together with them, the stakeholders often state their needs without considering each other because they are using their own means of communications and project management methods. Nothing tells them about the dependencies and risks associated with each other. So here is when the concept of cloud-based ecosystem becomes significant in empowering collaborations between stakeholders and engineers. It happens when integration of various subsystems is done over the cloud, producing a collaborative and centralized online environment to combine everything required throughout different stages of the project. This includes, but is not limited to, engineering software, project management, ordering systems, and lifecycle management. All the actions required to the project will be directly done on the platform and synchronized across the platform. This enables stakeholders and engineers to directly work and exchange information with each other because everyone is directly engaged in the process of decision making. They will also be able to keep track of the project progress easily so that everyone in the team is at the same pace to achieve the project deliverables. Besides that, with a centralized database, all of you can easily view the resources allocated to you as a whole picture. This helps your team to effectively manage and make use of the limited resources for your project so that you can allocate and make full use of your resources. So after the meeting with your stakeholders, your team now needs to modify the design. The flow at the center of the slides is actually a very simplified design flow used by the team. Now, the design engineer completes the first draft and sends you the design to perform a flow simulation. Since two of you are using software from different developers, they are just incompatible with each other. You took some time to import the document and only to find some of the design features have been missing. And after all the failed attempts to recover the details, you gave up. You have no choice but to tell the design engineer and wait for him to figure out a suitable file format. Then, after he's done, he emails back the file to you. As you may already noticed, a lot of time here have already been wasted just for importing documents and updating each other, instead of performing creative and productive tasks. This is because nothing is directly linking two of these tasks together. But this is not the situation anymore with a cloud-based software ecosystem. The cloud-based software ecosystem means all the necessary applications involved in this design process will be integrated with one another because they come from the same developer. And all the software are based on the singular online cloud-based platform. This saves the hassle of dealing with various file formats. And while working with each other, all changes made will be directly reflected and stored online. There's absolutely no need to exchange files through conventional methods like email, which helps to reduce risk of miscommunications. He can just inform you that he's completed the design and you can just straight away open and straight view the design on the cloud and run a simulation from your site. So this streamlined engineering process promotes real-time problem solving, which serves as a more efficient platform for your team to exchange ideas. And after the first draft, we now need to optimize our design by modifying the parameters, which is a repetitive and boring process if done manually. So remember the innovative process that I told you in the beginning? It was actually an automated optimization process. Let's say I have a combination of parameters from the number of gills, angle of attack, and offset between the wings. So using the cloud platform, I only had to specify the parameters. The cloud computers uses its algorithm to automatically evaluate some of the best possible combinations for you. So this reduces the numbers of simulations required. It then runs the simulation online and stores the result on the cloud automatically. If we think about it, this whole optimization process can be broken down into a few subtasks, including regenerating designs and meshes, simulating the scenario, and also evaluating the results. But now, with all of these tasks combined into one single program, the only thing that I had to do after specifying my input is to monitor the progress. By doing so, I can multitask by using the same time to work on other tasks or just simply sit back and relax. Even if the whole design process results in an exaggerating amount of file size, I do not have to worry about my storage devices because the files will be stored on an online storage. Besides that, the integrated software can efficiently post-process all the results from the study and visualize them using powerful visualization and scoring tools. This function is essentially important for us to study the relationship and correlation between parameters. We can see how they affect each other and which combination produces the design closest to our requirements. So this helps to speed up the process of decision making when we are trying to create our prototype. One more thing we value about cloud computing is the connectivity. So let us think. What happens if the movement control order, or MCO, happened 20 years ago and we had to stay at home? It probably just means that our project will come to a halt as we have no access to the software, hardware, and data stored in our company's workstation. But for now, the situation is completely different with the help of cloud computing. Since you are basically using an online office, wherever you are does not matter anymore. You can stay on track of your work as long as you have a smart device connected to the internet, and this provides an opportunity to work from home or working remotely from the office. Also, because the software are not directly installed on your computer, the hardware requirements for your computers can be greatly reduced. Simulation software often require computers with superior hardware properties for CPUs and RAM to perform complex calculations at an optimal speed, as well as disk to store project files. By using cloud computing to execute applications online, you do not have to carry bulky computers with sophisticated hardware around, nor do you have to purchase those equipment at high cost. Other than that, comparing to performing the jobs at your workstation, your project files are actually safer when they are on the cloud. Even if disasters like flood, fire, or theft happen and cause damages on your physical devices, your hard work will still be safe from these unprecedented situations because they are not stored inside these physical devices and they will not be damaged or wiped out. Lastly, cloud computers can be based on supercomputers, which offer extraordinary computing power to perform sophisticated tasks which humans and normal computers are not capable of. In the future, we may combine cloud computing with augmented reality, or AR, in our design task. We can, just maybe use a pair of VR goggles to simulate a very realistic virtual environment. And instead, using the mouse as an input, sensing devices can be attached to your hand to detect your hand gestures, so we can position our design parts according to how we imagine them in our brain. Cloud computers will then be responsible for executing more intensive tasks, for example, generating 3D graphics and also calculations. Also, remember how it feels like when you have to do prototype troubleshooting on the spot, or maybe you have a failed prototype, just because you fail to foresee the details for manufacturing. So now, with the help of AR, we may be able to have a glimpse of the final product, but without having to actually manufacture them out, which saves cost and time from prototype failures. The AR will also serve as a very interactive platform for us to present our prototypes to our customers in the future. We can use AR to demonstrate our prototypes to our customers even before we manufacture them out, and this turns what they are imagining into reality. Meanwhile, this helps us engineers to present our ideas and concepts in a less technical way. So, all this we have seen how digital transformation has brought our engineering experience to a higher stage. However, if we view all of these as a whole picture, there are still a few obstacles worth considering. First of all, the transformation process is highly dependent on the network infrastructure. All of the examples above become feasible only when there is a very strong and stable internet connection to link us to the cloud, or else only local computers can be used. However, the possibility of moving everything online is still very optimistic as we proceed to the 5G generation with a faster and better network coverage. Next, certain people may find cloud storage unsafe as it may be susceptible to attacks from hackers who are trying to steal information, as well as some end users who accidentally executed and uploaded malwares. This risk is minimized by cloud service providers by having multiple layers of protection and having a set of backup data. The service providers will only allow authorized personnel to have access to the data stored on cloud. Besides that, since this is a step forward from what some people are already used to, it will take some time for users to fully adapt to the new changes, especially in a team consisting of large number of people. Lastly, a large capital has to be spent in the beginning for purchasing the whole set of software ecosystem and subscribe to the cloud services. It will take some time before the direct and indirect benefits as a result of these spendings will be reflected on the statements. However, the fact is, moving to cloud computing can help to achieve savings in the long run. Companies only have to pay for the services that they use, which helps to cut down costs on device maintenance, storage, hardware, and also the IT team. These service plans are usually tailor-made, so the users are able to make their decisions based on the balance of functionalities and price. So as a conclusion, we saw how the utilization of these digital technologies and devices could transform our engineering experience to the next level. There's a very high probability that only organizations which have successfully undergone such transformations will survive, especially in this competitive era. Despite all the challenges faced, we can view them as a matter of time, and we can expect ourselves to embrace digital transformation for the next few decades. These are, in fact, only a few examples, and in real life, there are actually way more methods to achieve this transformation. We can start with small steps, for example, using the cloud as the storage method and a sharing platform for our school projects. Let us make full use of these resources to continuously make impacts and keep inspiring the world as engineers. And who knows, maybe we can turn the espresso into coffee dates, right? Yeah. So thank you very much for spending your time here and stay safe.